Welcome to Ask and Learn.
We would like here to find the bitwise OR, AND, and XOR of each of these pairs of bit strings. So I'm going to write them out vertically to make this a little bit easier on us. 1, 0, we got 4 ones here, 1, 1, 1, 1. Let's write this out a little bit more evenly spaced. 1, 0, 1, 1, 1, 1, 0. And then 0, 1, and then a ton of zeros until we get to 1. So bitwise OR for these guys is going to, each of these has a 1 in each of the components. So the OR is that. Bitwise AND, they each also have a 0. So 0 and 1 is always going to be 0. And the XOR, we notice that each column here has exactly 1, 1, and 1, 0. So we get that, which is great and good. Let's look at this next one. We got 4 ones, 4 zeros. 1, 1, 1, 1, 0, 0, 0, 0. And then we have alternating ones and zeros, like that. And we'd like to first find the bitwise OR. Let's see, well, this one is 2 zeros, which is a 0. This has a 1, no 1, 1. Each of these has a 1. Look at their AND. Let's see. Each of these has a 0, but these two are only 1s. So we got that. And the exclusive OR, let's see. Exclusive OR as a shortcut, you can just see if the bits are different, right? These are the same, these are different. Same, different. These are different. These ones are the same, these ones are different, these are the same. Right? And we can look at that in particular because 2 zeros and 2 1s each will XOR to 0. But if they're different, that's if the two bits are the same. If they're different, you got a 1 and a 0 and a 0 and a 1, then they will XOR to 1 because exactly one of them is 1. A little conceptual shorthand for the exclusive OR. Anyway, next thing. 3 zeros, 1, 2, 3, 3 1s, 1, 2, 3, 3 zeros again, 1, 2, 3, and a 1. And then we got 1, 0, 0, 1, 0, 0, 1, 0, 0, 0. All right, so bitwise OR is going to see this one has a 1, this one has a 1, these two are both zeros. These each have 1s, these don't, and this one does. So there's our OR. Our AND, you can see, let's see, these all have zeros in them, except this one here has 2 1s, and the rest of these, none of the rest of them have 2 1s, which is what's required to get to AND to a 1. With the XOR, again, we want to look at where they're different. Those two are different. Same, same, different, 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 same, 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 different. Which is great. That's cool. And our last string here is just a ton of 1s. So we can actually I'm just going to draw 5 as an example here, because all of the bits in each thing are going to be the same, right? XOR. The ORs are going to all go to 1 because each column has a 1 and a 0, but in particular it has a 1. The ANDs will all go to 0 because in particular they all have a 0. And the XORs will also go to 1 because they have each 1, 1, and 1, 0. And there we go. That's all the bitwise ops.